All right, class. This is example 4, okay? The continuation of our lesson in integration by parts. And in this lesson, what we're going to talk about is that some integrals require repeated use of integration by parts, okay? So I'm going to write that down here. So it's going to be repeated use of integration by parts. Okay? So repeated use of integration by parts. So in other words, the first 3 examples, you only did integration by parts one time. In this example, you're going to do it twice, okay? So the first thing we do is we use that acronym LIATE, or we can say mnemonic, okay? I say acronym, it should be really a mnemonic. All right, LIATE. And we got to determine what's our U and what's our DV, right? So let's take a look at this. So x squared is algebraic, and sine x dx is our trig, right? Well, algebraic comes first, then trig. So whichever comes first is going to be our u, and our trig is going to be our dv. All right? So we say, okay, well, this is going to be u equals du v dv. Okay? So our u is going to be our x squared, and dv is going to be our sine x dx. Okay? So the derivative of x squared is 2x dx, and v is going to be the integral of sine x dx. Well, that's just negative cosine x. Okay? So then now we set up our integration by parts. So we know that the integral of x squared sine x dx is equal to u times v, which is going to be x squared times negative cosine x minus the integral of v times du. So it's going to be negative cosine x, or yeah, you can just say negative cosine x. Go back to blue here. Negative cosine x times 2x dx. Okay? All right. Now, we're going to clean this up. Okay? So I'm just going to rewrite it to clean this up. So it's going to equal to negative x squared cosine x minus, now this minus right here, actually this minus can come out here. That's a negative 1. Can come out here and multiply to that negative 1. That's going to make it a what? A positive. Okay? So if I rewrite that, not only that, I can take out this 2, because constants I can always take out, right? So I'm going to take out a 2, and I'm going to be left with a cosine x. Actually, I could take out that 2, but I still have this x here, right? I got that x there. So it's going to be x cosine x dx, right? So those 2 negatives make a positive, and the 2 can come out, and I'm left with the x cosine x dx. Okay, so then now what do I do? Well, so I now have to focus in on this integral here, right? This x times cosine x dx. We'll see, the whole purpose of integration by parts is to take the integral of 2 parts, right? Of 2 functions being multiplied to each other, right? So therefore, I got to do the integration by parts with that. So therefore, I got to do it one more time. So I'm going to come down here, and I have a lot of space under it, but I'll go ahead and just use this space under the second time here, okay, where it says second time. And I'm just going to say, okay, well, what's going to be my u? What's going to be my dv? Same thing, right? X is my algebraic, cosine x is my trig. Algebraic comes before trig, and that LIATE, right? The LIATE. So the algebraic, which is my x, comes before my trig, which is my cosine x. So therefore, this is my u, and this is my dv. So therefore, I'm going to say u is equal to x, okay, well, u du. Let me just write them down first. V dv. So u is equal to my x, and dv is cosine x dx, right? Okay, so what's the so if x is u, what's the derivative of my u? It's going to be just dx, right? The derivative of x is just dx. And the integral of cosine x dx is just going to be sine x. Okay, so you write this in blue here. Okay, and then I set it up again. Now I'm going to rewrite the negative x cosine x plus 2, but then I'm going to set up this integral with integration by parts. Okay, this is what I blocked here in red. So here I go. It's going to be, now remember, I'm still finding the integral of x squared sine x dx, right? So it's going to be the integral of x squared sine x dx is equal to negative x squared cosine x plus 2, and here we go with integration by parts, okay? So I'll go bracket, and then it's going to be u times v, which is going to be x times sine x minus the integral of v times du, which is just going to be sine x dx. Okay, let me write that a little bit better. Okay, so it's going to be sine x dx. Okay, so sine x dx. And I'm going to block it off. And so here I go. So now I'm ready to distribute that 2. So I'm going to distribute that 2 into the parentheses, and I'm just going to clean it up. Okay, so now it's going to be equal to negative x squared cosine x plus 2x sine x minus 2. Now, I don't need to do integration by parts anymore. I can take the integral of the sine x dx that just as normal, right? What's the integral of sine x dx? Well, that's just negative cosine x plus c. And so I'm just going to rewrite it to clean it up one more time. So it's going to be negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. And that is my final answer. So this is an example of the repeated use of integration by parts, okay? So there's going to be times where you're going to have to do the integration by parts more than one time. In this case, it's only twice, right? So hopefully this helps you.